What's up? It's Mr. Wickelhouse, and today we are talking about Cpctc. This will be lots and lots of fun. What in the heck is Cpctc? What are you talking about, Mr. Wickelhouse? Well, I'm talking about corresponding parts of congruent triangles are congruent. Okay? So if we prove that two triangles are congruent, then we can show that all of the parts of those triangles are congruent. So in other words, if I prove a triangle congruent by side, 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 then I know that all the angles then are congruent. If I prove a triangle by side, angle, side, then I know that the other two angles are congruent and the remaining sides are congruent, and so on and so forth. So if I can prove the triangles are congruent given the information that I have been given, then I can show that the rest of the triangles are rest of the parts of the triangles are congruent as well. Cpctc, corresponding parts of congruent triangles are congruent. Let's do a proof. Okay. In this picture, they were nice enough to go ahead and label what we knew for us. So A, B, and D, E are congruent. Angle A is congruent to angle D. Side AC is congruent to side DF. And we need to prove that this angle right here and this angle right here are congruent to one another. In order to do that, we have to prove that these two triangles are congruent. Well, these two triangles ABC and DEF are congruent. How do we know that? Why are these two triangles congruent? I'm hoping you're saying that it's side, angle, side. So we have all those three things right in a row. The angle is between the sides. So this triangle is congruent, side, angle, side. After we get that, when we're writing our proof, then the last piece is easy peasy, lemon squeezy. So I've got AB congruent to DE given. I've got angle A congruent to angle D given. I've got AC congruent to DF. That's right, it's been given. Then I know that these two triangles are congruent by side, angle, side, side, angle, side. Lastly, I can finally state my proof statement. Angle C is congruent to angle F. And you're saying, what am I going to write here? Do I have to write corresponding parts of congruent triangles are congruent? No way. Just put C, P, C, T, C. And we are done. Done and done and done. That's not that bad. Proving the triangle's congruent, then the last step is easy, easy peasy. Okay. Here's a tricky triangle proof. Tells me that GH is parallel, these two lines next to each other means parallel to IJ. And it also tells me that angle IGJ is congruent to angle HJG. Okay? Well, how does that help me? Well, this is just obviously just some information. It doesn't really tell me anything else other than that these two are congruent. But how do these parallel lines help me? Well, I'm hoping you're thinking back to Unit 3, and at the end of Unit 3, we talked about parallel lines cut by a transversal, right? Remember that? Parallel lines cut by a transversal. Well, when I'm thinking about that, with these triangles and the shape, I'm talking in between these two lines. So I'm talking on the interior of these. And look, here's the transversal cutting these two parallel lines. We're inside of that. So look here. We've got an angle here. And we've got an angle here. What are those angles? They're inside. They're on opposite sides of the transversal. That means that they are alternate interior angles. And alternate interior angles are congruent. Remember? Okay, so then I know that IJG and HGJ are congruent to each other. Okay? Alright. I also know that GJ and JG is a line that is congruent to itself because it's the same line by the reflexive property. Right? Alright. That being said, I know that these two triangles are congruent by angle, side, angle now. Alright. So, let's do this stuff. Alright. I've got GH parallel to IJ. That's given. Okay. I've got GJ is congruent to JG. Why is this congruent to itself? By the reflexive property. Okay. IGJ and HJG are congruent to each other. That was given. Sometimes people will write the givens right next to each other, but you don't always have to. Okay. I also know, if you remember, that IJG is congruent to HGJ. Why did we say that? Why are these two angles congruent? That's right, they're alternate interior angles. And alternate interior angles are congruent to one another. Thus, triangle GJI and JGH are congruent by what? Angle, side, angle. Angle, side, angle. The last part now is easy. IG is congruent to HJ. Why is it? Why is it congruent? It's congruent by Cpctc. Okay? All right. Let's do one more. Here's another one that says AB is parallel to DE. I'm just going to go ahead and write that in here. AB parallel to DE given. Let's go ahead and write this. C is the midpoint. Midpoint of AE given. Why is that? Why is that? Or what do those things tell us? Why is what? You're probably saying, what the heck are you talking about, Mr. Wilcox? I don't know what I'm talking about, because I'm talking to a camera right now. So, AB is parallel to DE. This is the same idea as what we just did. So, let's see here. AB parallel to DE. Well, I'm feeling like, because here's an angle here and here's an angle here, that I might be using that. But let's see what the other bit of information is. C is the midpoint of AE. Okay, well, C is the midpoint right here. What's the midpoint? That's right, it cuts these into two congruent pieces. So Mr. Wickelhaus was right in his thinking that we're going to use angle A and angle E. Okay. Okay. This is saying now ABC is congruent to CDE. ABC is congruent to CDE. Well, that's okay too. But Mr. Wickelhaus doesn't want to do it that way. So we're going to say angle A is congruent to angle E by alternate anterior angles. Then I know that AC, angle ACB, is congruent to angle ECD by vertical angles. Okay. And I know that AC is congruent to CE because C is the midpoint. By definition of midpoint, AC is congruent to CE. Okay. Then I know that ABC, triangle ABC, is congruent to triangle EDC by angle, side angle. Then BC is congruent to DC by Cpctc. Okay? Alright. Now I challenge you to go back to this and think about how this would make these two triangles congruent as well. Alright? So think about that, see if you can write a second proof for this same thing. It just goes to show you there's multiple different ways to do these proofs. It just depends on how you think about it. Alright? I'll talk to you later. Have a fantastical day.